Hi Jen, thanks for sending in this question. Let's have a look at it together and see if we can get you to the answer. They were asking you, or they were giving you, the fact that you've got two cubic polynomials and they've been told that they have a common factor. All right, so in other words, when you factorize each of those polynomials into brackets, there's going to be a bracket that's going to be the same for both of them. All right, and we've been told that we have to find the value of k given that there's a common factor. Well, the expression that you have all the terms in is obviously the first one. Okay, so that's the expression of x cubed minus 4x squared plus x plus 6. Okay, we know all the terms over here. So if there's a common factor, well, that means that, well, the first thing I need to do is we need to factorize this polynomial, because I need to establish what the factors of this are before I can actually start thinking about the common factors between the two. Now, if you're factorizing a cubic equation, you are going to land up with 3 brackets, okay, as a factorized answer. So that's the first question you're asking yourself here. What are the factors of the first expression? That's what we're going to have to go ahead and do. All right. Now, just to point you in a direction, there is a video that we have got in our Keep It On Core syllabus, which is your section 6 for algebra in grade 12, and it's video 6.13. If you need to go and have some extra revision on how it is that we actually factorize a cubic equation such as this, please go and have a look at that video. It's explained in a lot of detail, and hopefully will actually give you a good understanding of how to go about doing it. However, that being said, let's have a look at how we go about doing this. So remember, when you're factorizing a cubic equation, you have to look at the constant term at the end over there. Whatever the numbers are that we use in the brackets of these the factorized answer, those numbers have got to be factors of that value of 6 over there. Okay, that is the bottom line, is that those actually have to be able to go into 6. So what are my factors of 6? Well, I know that 1 goes into 6 times. I know that 2 goes into 6 3 times, and in fact that's it. Those are the factors of 6. So the idea is this: we need to take any one of these numbers, all right, and we need to substitute them into the values of x. And what we are looking for is we're looking for an answer of 0, because the second we substitute one of those numbers into x and we get a value of 0, we can then make the conclusion that those are then your factors, okay? And actually we're just looking for one of them as a starting point. So generally speaking, you want to go with your lower numbers to begin with. Try and avoid the big numbers if we can. So we're going to start with positive 1 and we're going to substitute in. So this is how we're writing it. We're going to take f of 1, all right, this is what we're doing. We're substituting all our x's with 1s, and we're going to see what that gives us. So every x gets replaced with a 1, all right, and we work it out. So now that's going to be giving us 1 minus 4 plus 1 plus 6. That's giving me 6, 7, 8 minus 4, and that's actually leaving me with positive 4. So do you agree with me? I'm not getting a 0 there, all right? And if you're not getting a 0, that means that this is not a factor, okay? But what you do need to remember is that when we're considering these possible factors over here, you do need to take into account that it's either a positive or possibly a negative of one of those values. So therefore, if f of positive 1 didn't work, we need to try f of negative 1, okay? So therefore, we're going to substitute negative 1 into the x's. All right, and you grab out your calculator and you see if you can work out for me quickly what this gives you. All right, so replacing all the x's with negative 1s, you should be seeing that we're getting to an answer of 0. That is exactly what you want, because the second you've got that, you can make the following conclusion, all right? If the x value, if we know that x is equal to negative 1, then the idea would be that if if that negative 1 were to jump back over the equal sign, it would make the bracket of x plus 1, and we can say that x plus 1 is a factor. All right? So what we know right now is that this first bracket is x plus 1. Great. But what about these two? Okay, now we can sit and play trial and error for ages, but there's more effective ways to do it. Okay, and what we essentially now want to know is, if x plus 1 is a factor, well, how many times does it go into your cubic equation? All right, the cubic equation being again x cubed, let's just see, minus 4x squared minus 4x squared plus x plus 6. Okay. So now the idea is we need to take this equation over here, all right, this being your f of x, and we are going to divide it by your factor, all right, which is your x plus 1. We can do this by long division, all right, long division is one of the options, or we can do it by one of your shorter methods, okay. The method that I used in my explanation video in 6.13 is a method called synthetic division, and it's a method you can use, okay. Synthetic division works like the following. You take the coefficient, there's an invisible 1 in front of that x, you take the coefficient of each of your terms, okay, as long as they're also in descending powers of x, that's really important. So we've got 1 minus 4 plus 1 plus 6, okay? And we established earlier that x equals negative 1 was your factor, so we're putting negative 1 over there. And we now are going to do division. So the method of synthetic division is we bring our 1 down. Negative 1 multiplied by positive 1 is negative 1. Negative 4 minus 1 is negative 5. We're going to multiply negative 1 with negative 5, which is going to give you positive 5. 1 and 5 is 6. Negative 1 multiplied by positive 6 is negative 6. And this last term over here, if it's a factor, has always got to be 0. And now we put an x squared in front of this, behind that coefficient over here. We put an x behind that over there, and the 6 is your constant term. So we've got x squared minus 5x plus 6. That's how many times this x plus 1 goes into this expression over here, all right? So what you're now going to do is you're going to factorize that trinomial, which means we've got x and we've got x. Factors of 6 that are going to get you to 5, to get you to negative 5. 3 times 2 is 6, and if both of them were negatives, that's going to give you your negative 5. So if this trinomial, sorry, not trinomial, if that cubic expression is factorized, we said in the very beginning that the first bracket, which we found by trial and error, was x plus 1, and the other two brackets are x minus 3 and x minus 2, all right? Now that we've factorized this equation over here, now we go back to this and say, they told me that it's got a common factor. So if I take the second cubic expression, so x cubed minus 3x squared, x cubed minus 3x squared plus 2x plus k, plus 2x plus k. That's the second expression they gave us. They said that when we factorize this expression, one of the brackets is going to be common with one of the brackets in the previous expression, because they said there was a common factor. The problem, however, is we don't know what it is, all right? So we're going to have to then say, well, what if? So if the common factor is the bracket of x plus 1, okay, if that was the common factor, then we could make the statement that f of negative 1 is going to be equal to 0. Now, if that's the case, we would be able to take your expression, and everywhere where there is an x, you're going to replace your x's with negative 1s, okay? And remember, there's that variable of k, and what you're going to be able to make the expression equal to is 0, all right? And you're going to solve for your k, which I'll come back to in a second. However, if the common factor is the other bracket, the next bracket, which is x minus 3, All right. Then we would make the conclusion that f of positive 3 is equal to 0, and then you would do exactly the same thing. Instead of x's, we're going to replace every one of your x's with positive 3. And because we're making the statement that it's a factor, it would mean that we would be able to make the expression equal to k. And I'll come back in a minute and solve that. Finally, if the common factor was the last bracket, which was, what was the last bracket? X minus 2. Okay, then we would be able to make the statement that f of positive 2 is equal to 0, and exactly the same thing would have to happen everywhere where there is an x. We're replacing it with a positive 2. Sorry, that's a 2. All right. Your variable of k, and we make it equal to 0 because we are saying that it is a factor. All right. And if we go back and then actually work out what each of the values for k is just by working out all that substitution, the first possible value of k was 6. Your second possible value of k was negative 6. And your third possible value of k was 0, okay? So if taking into account any one of those brackets as a possible common factor, those would then be the 3 possible values for k. All right, Jen, hope that helps you. If there's any further questions, let me know. But otherwise, that is how you need to go about factorizing a cubic expression such as this. And as I say, that video here, this is going to be really helpful for you to go and have a watch and to see if you make, just to reinforce that understanding. Well done, Jen, and keep up the hard work.